Imagine shrinking down, smaller than a grain of sand, smaller than a cell. We're diving deep into the realm of atoms, the building blocks of everything we know. Get ready, because things are about to get strange. We're about to experience a reality beyond our wildest imaginations. Welcome to the quantum world, a universe within. Our journey begins at the edge of an atom. From this perspective, it's like approaching a colossal sports stadium. But instead of crowds and lights, we find a vast, mostly empty space, buzzing with a mysterious energy. This is the quantum realm, where the rules of our everyday world no longer apply. Hold on tight, it's going to be a wild ride. At the center of this atomic stadium lies the nucleus, a dense, tiny speck. If the atom were the size of that stadium, the nucleus would be like a marble on the 50-yard line. Don't be fooled by its size though, it holds almost all the atom's mass. Imagine squeezing the entire mass of the Earth into something the size of a marble. That's the kind of density we're talking about. This tiny powerhouse is made of protons and neutrons, particles bound together by an unimaginable force. They're packed incredibly tight, vibrating with an energy that's hard to comprehend. This is the heart of matter, the core of existence. It's a mind-boggling concept, but we're just getting started. Buzzing around the nucleus is a cloud, a blur of activity. These are electrons, much smaller than protons and neutrons. They're not like planets orbiting a star in neat, predictable paths. Instead, imagine fireflies flashing on and off, their positions uncertain, existing as a haze of probability. This is the Electron Cloud. It's not a solid thing, but a region where electrons are most likely to be found. They flit about in this cloud, governed by the bizarre laws of quantum mechanics. These laws defy our everyday intuition. They tell us that particles don't exist in one place at one time. They exist in a state of possibility, like a coin spinning in the air, both heads and tails at once. Electrons, those tiny sparks, aren't just randomly zipping around. They occupy specific energy levels, like living on different floors of an apartment building. They can jump between these levels, but not by simply traveling the distance. They vanish from one floor and reappear on another instantly. These jumps, called quantum leaps, are how atoms absorb and emit light. Think of a neon sign. The vibrant colors come from electrons in the neon gas, making these quantum leaps, releasing bursts of light. It's a beautiful example of the quantum world influencing our everyday experience, but the rabbit hole goes deeper. The glue that binds. Let's zoom back to the nucleus, to those huddled protons and neutrons. Remember that incredible force holding them together? That's the strong nuclear force, the strongest force in the universe. It's like a superglue so powerful it dwarfs gravity's pull on these tiny scales. Imagine trying to stick two magnets together with the same poles facing each other. They repel, right? Protons, being positively charged, should do the same. But the strong force overcomes this repulsion, binding them tight within the nucleus. It's this force that makes atoms, and therefore us, possible. Deeper still, the realm of quarks. But even protons and neutrons aren't the end of the story. Inside these particles lies another layer of reality: quarks. Quarks are even smaller particles, the true building blocks of matter as we know it. They come in different flavors, like up and down. Holding these quarks together are gluons, aptly named because they act like a cosmic glue. They flit between quarks, exchanging a force that's even stronger than the strong nuclear force. This interaction is a frenzy of energy and activity, a microscopic ballet of creation and annihilation. So, we've journeyed into the heart of the atom through protons, neutrons, even down to quarks and gluons. What have we learned? Perhaps the most startling fact is this: atoms, the building blocks of everything we see and touch, are mostly empty space. If we scaled up an atom to the size of the Earth, the nucleus would be just a few hundred meters across. Think about that for a moment. The chair you're sitting on, the device you're reading this on, even your own body, are mostly composed of nothing. It's a mind-bending concept, like an ocean with islands of matter separated by vast distances. But this emptiness isn't a void, it's teeming with something far more profound. This emptiness within the atom isn't really empty, it's buzzing with energy, a quantum foam of particles popping in and out of existence. These virtual particles appear and disappear in the blink of an eye, influencing the behavior of the atom in subtle but crucial ways. This is the essence of quantum mechanics, a reality where emptiness is an illusion, where particles can be in multiple states at once, where energy fluctuates in and out of being. It's a world stranger than fiction, yet it's the very foundation of our reality. The deeper we dive into the atom, the more mysterious it becomes. Quantum mechanics reveals a reality that defies our everyday intuition. Particles aren't just particles, they're also waves spread out over space. They exist in a superposition of states like that spinning coin until we try to measure them. And then there's entanglement, where two particles become linked. Their fates intertwined no matter how far apart they are. It's as if two coins, flipped on opposite sides of the world, always land on the same side. These aren't just theoretical concepts, they're demonstrable realities. They point to a universe far stranger and more interconnected than we ever imagined. Our journey inside the atom has been a mind-bending adventure. We've encountered forces beyond our comprehension, particles that defy our expectations, and a reality that challenges our very understanding of existence. But more than anything, it's filled us with a sense of awe. The atom, once thought to be the smallest, simplest thing, is revealed to be a microcosm of the universe itself, full of wonder, mystery, and endless possibilities. It reminds us that the universe holds secrets upon secrets waiting to be unlocked. It's a call to exploration, to keep asking questions, to keep pushing the boundaries of knowledge. For in the heart of the atom we find not just the building blocks of matter but the building blocks of understanding.